Hello to all participants, and thank you for your support and participation to the Safety Gala event. We are running the 8th session of the day regarding with the topic regarding intelligent safety risks prediction. As we all know, digital transformation has been taking place across many functions within organizations over the past decade, and this has been accelerated dramatically due to the pandemic, driven by the need for workers to be safer in a new hybrid way of working, and put even greater focus on the importance of health, safety, and well-being of the workforce. So our session aims to highlight how modern intelligent systems and applications assist to the prediction of risk and distant prevention as well. Our speaker will present intelligent good practices that are applied, and of course will give answers to your questions about the current and future developments. So don't forget to submit your questions to the QA. We will start our session with Dr. Michela Hadjimichailidou. Michela is a system safety specialist, currently working at Arup UK as the Global Rail System strategist. She has a leading role in Europe's most complex major project, High-Speed 2, and is a member of the Integrated System Safety Team. Her project portfolio includes projects spanning transportation, construction, healthcare, and robotics. She is also committed to developing strategic partnerships between Arup industry, academia, and policy. Michela has a PhD in Social Technical System Safety and Human Cognition, a Master of Science in Civil Systems Engineering, and a Master of Engineering in Mechanical and Manufacturing Engineering. She has previously worked as a postdoctoral research associate at the University of Cambridge and Imperial College London and WSP UK. As we all know, safe construction requires care and planning throughout the project life cycle, from design through construction, planning, and execution. Building Information Modeling, BIM, offers a simulation of all these stages and can influence site health and safety management. Presentation of Michela summarizes the existing literature on the application of BIM technology in the safety management of the construction industry and in general, the main safe hazards of modular construction. Michela, the floor is yours.
Thank you so much, Theodoros, for the very generous introduction. Without further ado, I will just share my screen. Please let me know when you can see the slides.
We can.
Okay, lovely. Thank you very much. Thank you, everyone. Good afternoon, actually, from Athens. I'm on holiday, but normally based in London. As Theodoros mentioned, I'm currently working as a consultant for a major build environment consultancy called Arup. And I'm working in the field of system safety on all sorts of major projects with predominant focus on rail, like High-Speed 2, Crossrail, and so on and so forth. But in today's presentation, I'm actually representing UCL, University College London, which is the university where myself and my master's student performed this piece of work, which I will try to very briefly present to you. It's a very, very long project. It lasted 8 months altogether. So I will give you just some teasers, but please feel free to download the full journal paper published in the Journal of Safety Science. And of course, reach out to me if you would like a copy. The title is exactly the same as you can see it on the screen. So this is the overview of the paper. My student is called Yuma, and she's now based in China, working in major construction industries. Construction is considered mainly from a building perspective in today's presentation. So it's mainly residential buildings we're talking about. It's not about major projects. It's not about anything else that could be translated as construction, just residential buildings. And we will focus specifically on modular construction, which is a very new approach to construction, which tries to achieve economies of scale. So the scope of the paper, which, as I said, I'm going to touch on very briefly today, is quite a wide scope. As you can see on the left-hand side, it touches on 3 different overlaps of major topics: BIM and modular construction, BIM and safety management, and third but not last, modular construction and safety management. But the contribution of the paper is actually the cut, if we can consider it as a Venn diagram, the cut between the 3 very important areas / innovations in the area of construction. And this is what we're going to focus on very briefly today. So before I start presenting to you the results of this extended literature review, I want to give you very quickly some definitions or facts around the 3 major components of this work, which is construction safety, BIM, and of course, modular construction. So you are specialists and experts in the area of safety, so you will be very well aware of all the safety risks that come along with construction. So just to give you a fact based on the Health and Safety Executive in the UK, construction, as you can see on the screen, is one of the most hazardous industries. Unfortunately, and this is why us safety engineers are very useful really in this industry. And some facts really, compared to stick built, which is, let's say, the traditional way of building our residential buildings, modular construction has environmental, economic, and societal advantages. It's a very different way of building. It's more like a manufacturing process rather than the traditional construction process. Of course, as everything really in life, it comes at a cost in a sense that any innovation should be considered from a safety perspective because it may introduce some safety risks, of course. And then another fact which I came across during this long analysis published by the United States Bureau of Labor Statistics says that unfortunately there is evidence of increased injuries and fatalities in the US modular construction industry, which means that it is an area which, yes, on the one hand it may bring major advantages, but on the other hand it needs to be considered from a safety perspective, and this is the main reason why we did this analysis at UCL. So touching on modular construction, as I said, it's more like a manufacturing process, like a production line. Consider it as Lego pieces. So you just produce a module, and then with that module, by combining it with other modules, you can create all sorts of outfits or different buildings in our case and layouts. And there is a process, a general process. Of course, bear in mind that processes may vary from industry to industry, from country to country. A very generalized process, which you can also find in the paper, is presented on this screen. As I said, typical production line process. You have the material production, which is then transported into a plant in order to fabricate the module, the entity which is going to then be used as part of the production process in order to create the final building. And of course, you have design at the top of the whole process, which obviously leads from a digital perspective the entire process. And building information modeling in its own is a very extended topic really, and for this reason, I decided not to say much about it. I know different specialists in different industries experience it in a very different way. The only thing I want to highlight here today is that it's not only about CAD designs, because many people tend, unfortunately, to oversimplify it. So it's much more than that. As you can see on the right-hand side, it encompasses laws and regulations, design, simulations, document management, anything really you can imagine that is related to the production process of a modular building. And it's obviously computer-aided modeling. So keeping this fundamental about this. So why is it so important? I already touched really on that, why it's so important to consider BIM safety management in modular construction as one topic of interest. So there is a number of papers in the literature, in the academic literature, as I mentioned in the beginning, that consider the use of BIM in modular construction. Then they consider the use of BIM in safety management, and as a third and separate topic, they consider safety issues in modular construction. But they never consider those three together, which is actually where the power of BIM can be highlighted, because BIM can be used actually to remedy, to mitigate safety risks which are pertaining to modular construction. And as you can see at the very bottom of the screen, from this literature review, we have identified three major areas where BIM can contribute to modular construction. The first one is training and warning for increased risk awareness by the workers, by the building workers. Safety inspection, so we go on site, say for example, where the building starts being created, and then we run inspections with the support of BIM. And then crane management, of course, which is another very, let's say, area. It's an area with a high safety interest. So let's try and unfold all these three separately. And I will make a very quick recommendation also by category. So training and warning for our workers. Offsite production of modular buildings, which means while it's still in the plant during the manufacturing process, requires workers to master a completely different set of skills. It's not like the traditional stick build. So they need to upskill themselves around new skills in order to be able to produce modular constructed buildings. And of course, pre-training, as always, can help all these workers really to understand the new nature of hazards that are introduced with modular construction. So the recommendation we made in our paper, by analyzing tens and hundreds of papers, was that visual, virtual, and interactive environments supported mainly by BIM can actually serve this purpose. They can give workers the capability and the capacity to check all these technologies, new methods really of construction, understand the safety risks that come with that, and eventually be able to contribute to the mitigation of those risks. But it's not only the workers, it's also the managers that monitor the whole process, as well as the designers that produce the building itself. Just to give you a very quick example, as you can see, it's a very complex picture, a very complex process as well. You can read about it in the paper. I'm not going to go into detail. The only thing I would like you really to focus on is, if you can see on the left-hand side, we have just a typical 4D representation of the site. There is no other, let's say, complexity being added or layer of information. But while you flow or follow the process to the right, you see that we add cranes as well, as you can see in the middle of the screen. And last but not least, we also add the human in the loop. So by using virtual reality in combination with BIM, we can create a dynamic environment, a live environment, where actually the worker feels the space and may feel the safety risk as well while being in this virtual space, which very characteristically and realistically represents reality and how the building will be once built. The second area, which, as I said, we identified as one of the most important ones, was safety inspection. So it's vital during modular construction to be able to understand the safety risks of this process as early as possible, mainly from a cost perspective, but obviously in order to mitigate safety risks for the people involved. So after a module is manufactured and before obviously being transported on site, needs to be monitored and inspected to see if there are any oversights or any issues with the structure itself. And of course, when the component is also transported, it has to be inspected again in order to make sure that all the models will fit properly, and of course ensure the safety of the building itself. So how can we do all these different, very complex processes of inspection? Again, with BIM, the extended literature review has shown that from manufacturing of the module to construction of the modular building, a beam-based dynamic tool can help us really and can guide us actually from conception to design to construction and to delivery to monitor all the safety risks involved, and obviously those risks are related to defects that the material and the module may have. So as an example here, I have a couple of examples. I'm not going to go into much detail. So there are a couple of different ways that BEAM can help us really do inspection of modular construction. The one is through a set of requirements. So because with BEAM, we're able really to gather information from previous projects and use them in combination with information from the ongoing project, we can create this kind of dynamic and also based on history set of criteria and quality requirements in order to generate or maybe better enhance a BEAM model, which is going actually to generate automatic inspection rules based on weeds. There are going to be some red flags, which we as safety managers need to bear in mind in order to do a proactive safety risk management. And of course, you can also use it in a more visible way, because the previous one was more about checks that we will be able to do. But when it comes to the visible representation of the risk, you can see at the very bottom of the page, there are different models that can actually color the areas where modular construction is developed, depending on how risk-prone those are. Of course, the more red the areas are, the more risk-prone the process, in a sense that, for example, workers shouldn't be approaching this area at all. Say, for instance, because a crane is operating and it's lifting extremely heavy modules of around 2 tons, so it's obvious that they shouldn't be in that space. So much information again around those two examples, which unfortunately I can't go into much detail due to time constraints, but please feel free to ask questions or go to the paper. And last but not least, crane management. As I said just earlier, the modules can weight, each module can weight up to 20 tons. It's massive, which means that there is definitely a very serious safety risk that needs to be considered. And therefore, this is where BEAM, as I just said earlier, can help us actually create heat maps in a way of the site in order to know where it's dangerous to step in when it comes to the site. And an example, a very easy example, you can see again, the red area in this heat map is the space where the crane operates heavily and also lifts heavy loads. And of course, no worker at all should be nowhere near this space. And of course, there is positive feedback from different operators, crane operators, because obviously those tools have been used in practice and operators have provided feedback, either positive or negative. Here we have a positive feedback from them that it made them feel more confident as well in the work they are doing as crane operators. As I said, more examples can be found in the paper. More specifically, there are 74 papers being analyzed. You can find all sorts of examples with all sorts of levels of complexity, programming, and so on and so forth. So please go ahead and have a look. And to summarize really this presentation, because I understand there has been quite a lot of information for you really to process, a few things really I would like us to take away from today's session is that it's a completely different set of skills required from workers in order to be able to deliver in the space of modular construction. It's by no means the same as traditional construction. It's very demanding in terms of planning phase, because it's different. As I said, it's more like a production line. So upfront planning and design and training is highly needed. And of course, it's a complicated process. Of course, large scale machinery, as I said earlier, to produce a 20-ton module, you need a very, very big machinery to be operated. And of course, as I said earlier, BEAM seems to be, it's not a panacea, let me clarify that, but it seems to be one of the solutions we have available at the moment that sounds promising. So it can improve worker safety, can improve awareness of risk as well, because it's very important to be able to be proactive as well. It gives us this visual sense of the space, and as I said, this enhances our safety awareness. And it can also generate early warnings as well. So in some cases, it can generate, say, for example, a beep sound. So we can act accordingly. And of course, we can check for conflicts in the planning phase. Say, for example, conflicts which have to do with technical requirements, for instance. So it's not only about safety, of course, but here we care about safety mainly. And some final mainly observations. This paper didn't consider material and equipment defects, transportation of modules or damage of modular components, because it was out of scope. It was already a gigantic effort. So we stopped there. If anyone is interested, really, I would be very happy to see more work being done in this space in the areas we haven't covered. Also, virtual reality, which I very, very briefly mentioned, geographical information systems, augmented reality, they are siblings to BEAM, I would call them really. They can complement each other in a very nice way. And there are examples in the literature and in practice that these are used in my own company, Arup. We also use them in real life examples. And something else as a recommendation, because I keep teaching at the university, really, I would like really to see more material in the syllabus around BEAM and VR and all these new technologies, really, because these are not the future, these are the present, really, and they are happening. And of course, last but not least, I think you are already very well aware of that every project is a single project usually. So usually you can't replicate same processes, same thinking. So we need to be very mindful of that, really, and not apply any approach in a hasty way, like everything, really. And last but not least, social value. I mentioned skills. We saw in the UK specifically, because I've been working with a major construction company called Linerwork. In the UK, we have seen that we can also help underrepresented groups of people, say, for example, people that were prisoned for a while. We can help them really upskill them, reskill them, and bring them back really to real life, to active life, and ask them really to become part of this process. It can also elevate societies that financially are not doing very well by building factories there where we can produce models, really. So just to highlight that everything we do as engineers, I'm an engineer myself, it always has to come with a social benefit. And this is the last thing really I would like us to remember after this presentation of mine. And thank you very much. Thank you.
Michaela, thank you very much for your magnificent, superb presentation.
Thank you very much.
Questions are coming. We will summarize them at the end of the session. I would like to present now Mr. Asterios Iagios. Asterios has studied chemical engineer at NTUA and business administration at Alba. He started his career at the petroleum refinery in 2000 and moved to Hellenic Petroleum in 2004, where he worked in the Department of Process Engineering, Production, and Oil Movement. He has been working in the health and safety sector since 2012, while today he is the Director of Health, Safety, Fire Safety and Environment of the Elefsina Industrial Complex of Hellenic Petroleum. His presentation is about airborne safety is airborne, drones in refinery health and safety applications. Drones are now being used widely across almost every industry to scope out sites, real-time inspection, and identify problems that would be difficult to predict without a high-resolution aerial view. Capable of monitoring sites through aerial mapping, drones can minimize the need to put workers in cages and harnesses, and ultimately reducing safety hazard, as well improve site safety monitoring. Asterios will present case studies and good practices already applied in the industry and the refineries with use of drones. Asterios, you can start your presentation.
Thank you. So, ladies and gentlemen, safety is airborne. For us, this is a journey. We are in no sense in the end of this journey, not even in the middle, but we are learning as we go how to use and how to utilize drones and robots in the oil and gas business, and in the specific case in our refinery. So, rephrasing the song, safety is in the air. We use them for HSE monitoring in large-scale projects, such as refinery turnarounds, in working at height, in confined spaces, underwater, for leak detection, and for emergency response. In turnarounds, for those that are not familiar with the oil and gas business, refineries tend to stop their operation every 4 to 5 years in order to do what is called the general turnaround. That meaning putting the equipment out of operation and doing cleaning, inspection, maintenance, and new projects. That may mean that you have an additional workforce of about 1,000 to 2,000 people each day. Work carried out in a large area and at the same time in height in congested areas. So one solution is to have an army of safety auditors, safety officers. The other solution that we have been applying the past few years is to have a power multiplier, such as is using a drone. And to give a very vivid image of how we use them, if anybody has seen the movie Lord of the Rings, there is the evil eye of Sauron watching over everything. This is us. Using a tethered drone. Tethered drones, i.e. drones connected to a cable that transmits power and data, gives the, in contrast with free drones that are just flying around, gives the opportunity of much longer flying time and much faster data transmission. It can give, in quotes, a 24/7 live feed. That is not realistic, meaning that drones have engines and batteries that become heated, and sometimes the weather conditions do not allow it, but let's not go into a great detail. We can easily see works performed over a large area. We have an eye in the sky. We can see work carried out at height and elevated equipment, which is problematic because safety officers had to climb 6, 7 stories of stairs in order to have a look at the work, and then they would have to do it again and again and again. We can have a very high focus, sometimes using cameras, high resolution cameras, to see details of the on the personnel, on the way of work, on the area. There is a capability for IR, i.e. to have night vision. We haven't found this to be very useful in safety, but it might be very useful in emergencies. And all this data is communicated through the radio or through HX phones to our boots on the ground, to safety officers that are on site and can go and handle any issue. Advantages is targeted use of resources. Officers are not just walking around waiting to see something, but are focusing on based on information given by the drone operators. There is a continuous visibility of elevated or remote areas, whereas in the old days this wouldn't be possible. And there is the possibility, the potential for recording, which is very useful, for example, in incident or near-miss investigations. An obvious area is working at height. For example, visual inspections of refinery and tank farm lighting pillars. We have done about 150 pillars in less than 5 working days. Visual inspection and level 2 NDT report. Visual inspection of lightning rods. Older lightning rods might have ionizing edges, which is more or less radioactive. So you don't need to expose people to working at height with cranes, with rope access, with scaffoldings, and all the risks related to that. Optical and IR inspection of the refinery flare. Flare is, for those that are not familiar with the business, flare is where we burn everything we don't need. And it's a safety system, more or less. This cannot be inspected during operation by a human, but it can be with a drone that can also, using IR, see defects in operation and give a heads up to the maintenance team to acquire spare parts and skilled labor in order to do the maintenance during a turnaround. Visual inspection of a decommissioned boiler stack. If something is decommissioned, not in operation, but not yet deconstructed, we can have a look at it from time to time to see if it's still okay. So we are saving time. Obviously, cranes, scaffoldings, rope access take time. We're saving money for exactly the same reasons, and we're saving risk when we use the drone to have an optical inspection, a visual inspection. That means that no one climbs up, so no people, inherent safety. And of course, there is timely inspection of equipment while in operation that wouldn't be possible without a drone. Working in confined spaces. On the right, you can see a specialized drone for confined spaces. There are some models now in the market. For example, we had a coker reactor out of operation. These reactors tend to have coke formations that can be like in a cave with stalactites hanging over people's heads. So we can visually inspect it and check this situation before we go in and take the relevant precautions. We can and we are inspecting external floating roof tanks, their grounding, their connection to the tank shell while they are in operation, using a drone and its high resolution cameras without having to go up and in, which is hazardous as a work, but also as a potential emergency. Again, we save time, we save money, and we save a lot of risk, reduce the risk. Working underwater. This is in a pilot stage, meaning that we have just started experimenting with this, using an ROV, like the one we see on the top right. What we can do is visual inspection of piers, water basins or pumps, which are both underwater and a confined space, not just open sea. These ROVs have 2D or 3D image sonars. They have QPS, which is like the GPS for the sea, a robotic arm to move or handle small objects. They can do ultrasonic measurement in metallic objects, so you can have an NDT inspection. Water sampling for environmental reasons, pH sensor for the same thing, and an AR ruler, more or less a laser ruler to accurately measure things underwater. We save money because divers sometimes also take time, but they mostly take money. And of course, a lot of risk because diving operations are never risk-free. Leak detection, that is more or less cutting edge right now. We have done a test which was positive, which the results were very encouraging. An optical gas imaging camera, like the very well-known FLIR, mounted on a drone and coupled with artificial intelligence, which can detect vapor organic compound or noxious gas leaks while they're happening. And in contrast to doing it manually, you can easily access elevated equipment, pipelines or reactors, and you can do it many times a year, whereas with an operator or a technician, that would take forever and usually limited to what is at ground level or at a safe access level. This artificial intelligence can even detect leaks that do not emit gases, because it can compare with data analytics, compare the picture before and after, and see that something that was gray, i.e. concrete, now it's black because it has fuel oil on it. Obviously time, obviously money, obviously risk, and a great help to the environment. This is also experimental. We have done many tests with in drills using free drones or tethered drones to transmit really live feed to the crisis command center in order to make decisions and inform people accordingly. It can also be transmitted to the authorities, the fire brigade or national authorities, police, whatever is needed. Free drones can also be used for situation assessment, meaning if there's a vapor cloud or a fire with a thick smoke and you don't want to expose people to that hazard, you can send the drone to have optical or IR or in case of oil spills, LiDAR, or in case of leaks and optical gas imaging, take the person, keep the people, the emergency responders away from the hazard as much as possible. Robots are not drones, but it's very relevant. On the top right, you can see an example of a robot used for firefighting. These robots have water and foam capability for extinguishing. They have optical, IR, and gas measurement sensors, among other things. And sometimes they also have a robotic arm that can open and close valves and switches or move objects. And to make it more dramatic, drones and robots get up close and personal in order to acquire and transmit data and or help us to respond to emergencies while keeping our people out of harm's way. Concluding and quoting Michela, are drones a panacea? I always like to use a Greek word. Like the movie Big Fat Greek Wedding, every word is Greek. Drones drastically reduce human exposure to hazards, can access high-risk areas during operation or during emergencies, can cover large areas and distances in a fraction of the usual time, and can provide live feed data streams from many different sources. They are not a solution to all problems and all diseases, but they are a versatile and cost-effective tool. Thank you for your time and patience, and I'll be eagerly waiting for your questions.
Thank you very much, Asterios. You save us 5 minutes from your presentation, so I'll take advantage of this benefit to give you a question until the next presentation. What are the concerns or the problems that you have captured until now from the implementation of this new technology?
Thank you, Theodore. One, for the time being, drones are not ATEX. They are not explosion-proof. That means that with the exclusion of emergencies, for I believe obvious reasons, where you weigh the risks, you cannot use them in potentially hazardous atmospheres in them. You can use them around them, but not in them. Flammable or explosive, you can use them in nitrogen atmosphere, no problem. Another problem is GDPR. More or less, you have to be very aware of potential issues with personal data, sensitive personal data, and the relevant legislation. You also have to be aware that in such an environment, not for example in the construction business, but in a refinery environment, you have to be aware that there might be interference, electromagnetic interference, or obstructions from the metal structures like a Faraday box that may interfere with your ability to operate the drone remotely. Last but not least is, as in every project, resistance to change. And resistance to change comes from people that are afraid that robots will take our jobs and will rise and take over the world, etc., etc., which is not the case, but we have to educate people that drones are tools. Drones send data, and people are needed to interpret this data. They do not take our jobs, they take the risk out of our jobs. So, right. For example, underwater, if the ROV finds something, you still need the diver to fix it. The drone cannot fix it for the time being. If you do a UT measurement with a drone high up in the air, maybe you get the data, but you need a level 1, level 2, level 3 NDT inspector to analyze the data and produce a report. And sometimes you need a person to go up there one way or the other and fix it. So they don't take our jobs, they make our lives easier.
As you say, make our lives easier, safer, and it's a transformation process. It's not a replacement process.
No.
Thank you very much, Asterios. Some more questions in the end of our session. I would like to introduce now Mr. Tim Trigenza. Excuse me if I'm spelling it wrong. Tim is a senior network manager at the European Agency for Safety and Health at Work. And after working as an inspector in the UK HSE, he joined the European Union OSHA in 1999, where he has worked on a broad range of health and safety topics. His presentation is regarding impact of digitalization on risk assessment and management. Digitalization nowadays is becoming so extensive and has the potential to affect almost everything and everywhere. And while it's very easy to be seduced by all the exciting engineering and technology, what sits behind this innovation, it is crucial that we do not overlook the considerable impact it will have on how we manage risk. So Tim's presentation looks at the broad impact of the digitalization of the work on occupational safety and health, and the prevention process, not only what should be covered, but also how the risk assessment may be done in future. Tim, we're looking forward to hearing all the news from you.
Thank you very much. I'm just going to share my presentation. I hope now you can see it. Thank you very much for the introduction. I regret that I don't have the Greek language, so I am going to have to speak in my mother tongue. So the European Agency for Safety and Health at Work is Europe's information agency for occupational safety and health, and we cover a very broad spectrum of topics, and we produce information for literally everybody, from workers, supervisors, safety professionals, policymakers, researchers. We reach out to everybody. And I'm talking today about digitalization because this is a huge topic we've been covering for the last 2-3 years, and as you will hear, we're moving forward with it in the next 3 years as well. And what we're talking about here is a change that is happening. Workplaces are changing fundamentally, perhaps even more fundamentally than when computers were first introduced to our offices. It will affect virtually everybody, where we work, when we work, how we work, what we work with, and with whom we work. And the range of technologies that comes under this big label includes the Internet of Things, cloud computing, use of big data, artificial intelligence, the platform economy, collaborative robots, augmented reality, drones, as you've just heard. And we know that some workers will benefit, others will not. Some jobs will disappear, and many new jobs will be created. And this is, as has been said, this is happening. It's not that it's intrinsically good, it's intrinsically bad, it's a change. What is not changing is the fundamental legislation in the European Union relating to the prevention of harm to workers. That is, and we start with the Framework Directive 89391 EEC. In short, this directive says that you will protect all workers from all hazards and risks. That's a very brief summary of the legislation, but so the workplace is changing, but that baseline European legislation is not changing. But there may be new legislation on new topics. For example, some member states are already putting into place right to disconnect legislation, and other non-occupational safety and health legislation may become much more relevant. And as has been highlighted earlier, data protection. This is at the core of the concerns maybe about digitalization. If you're like me, you wear a smartwatch that measures my heart rate. That's jolly good for me when I'm practicing for my runs. But what if that data is being provided to my employer? That is medical data. So there is a broad range of topics covered under the theme of digitalization. And I stress, digitalization is here. And we did a survey here at EU Washer last summer, and we saw in our responses, this is 25,000 working age people across the 27 member states. Over 10% of workers reported that they are using wearable tech last summer. 5%, about 5% are using AI, working with AI, and I think it was 3% with robots that interact with them. So these are big numbers already, and only 12% of workers reporting using no digital technology. So it's here, it's now, it's changing, and we've got to adapt. That's as safety professionals, health professionals, employers, workers, whoever. So I said we've been carrying out here at the agency for the last 3-4 years a lot of research into digitalization. And we move to the next stage now. And in October, we will launch a very large campaign, which will run for nearly 3 years on the theme. And what we do is we have 5 subtopics here. And the 5 subtopics are remote work, smart digital systems for the improvement of health and safety at work, digital labor platforms, advanced robotics and AI, and new forms of worker management based on AI. And what we do in the campaign, if you haven't engaged with us before, we produce materials in all member state languages, as well as Norwegian and Icelandic. And in fact, we also may be translating materials into the languages in the Western Balkans and Turkey. And then we organize a lot of events. And in each of our member states, we have what's called a focal point. So an organization and a particular person in that organization who carry out activities on our behalf. So you can contact your national focal point, and they may well be doing workshops on these topics. So what I'm going to do now is go into each of these topics in turn and highlight some of the issues. So remote work. Nowadays, I always define work time as BC and AC, before COVID and after COVID, because COVID changed work. And in particular, one of the things that changed was how we saw work and the workplace, because we all got locked down, or at least I did in Spain. And all of a sudden, my sitting room is now my workplace. But the legislation, the framework directive, the workplace directive hasn't changed. Remote work's a bit broader than that. You have a lot of people whose car is their office. There are people who do hybrid working in another workplace. Think about temporary agency workers, for example. Many people do not have a desk in an office or a workstation in a factory that is their workplace anymore. But the employer still has to protect that worker at work through the hierarchy of prevention that's set out in the framework directive. So we're talking about risk assessment, elimination, substitution, and so on. There are challenges there, particular. How do you carry out a risk assessment about in somebody's kitchen, for example, if that's where they're working? How do you implement any preventive measures? And how do you monitor the implementation of those preventive measures? Now, it's not as frightening as perhaps that sounds, but employers need to be putting in place an approach. In fact, I would refer back, there is in fact a framework agreement on telework, which was drawn up by the European social partners all the way back into 2002. And I do recommend reading it because it was written with great foresight, 20 years before COVID. And a lot of it in there is still relevant. And in fact, the social partners are now already drawn up a new framework agreement on digitalization, which will take their work forward. But yeah, digitalization means you don't have to be physically present. Exactly like I am sitting here in Bilbao talking to you wherever you are in the world. 10 years ago, I would have had to be sitting with you in a conference center in Athens or whatever. Second theme, smart digitalization, smart digital systems for the improvement in occupational safety and health. And here, as we've just been hearing, there are new technologies that really do offer real advantages in the workplace for improving worker protection. Environmental sensors, biomonitoring devices, wearable technologies, getting real-time feedback, accessible video and analysis for musculoskeletal disorders or ergonomic analysis, use of drones, as we've just excellently heard. These are tools, and it's important to see them as tools. They are not panacea, as has been said, but if you use them right, they can remove the worker from harm. They can early identify problems. For example, there is work going on for firefighters, I think particularly led out of Cyprus. And here you are seeing firefighter clothing designed with thermal sensors embedded in that clothing. The data is relayed in real time to the control center of a firefighter, and it allows the command officer to monitor the situation of those workers and identify real-time hazards and risks, and if necessary, pull the workers out of the situation before they are harmed. Now, yeah, as you've heard, there are many potential approaches and many benefits for this, but we have to always take care. One, of course, is data reliability and misinterpretation of data. Data reliability is something to take care of. In the example I've given, your thermal sensor on your clothing is not giving your body temperature. It's giving the temperature on that where that sensor is. And that may not give a reliable indication of the thermal environment. Misreading data is as old as data. Over-reliance on automated systems. At what point as a health and safety manager do you override the system? what point do you say, hang on a tech, I don't think this system is working properly? And on what basis do you make those decisions? Alternatively, if you are a safety and health manager, you may simply get a data overload that makes it more difficult for you to make proper decisions. I mentioned earlier the issue of data security, especially medical data. There are within the European Union, this is a hot topic. This is a real discussion, and this is the biggest challenge, I would say, in the digitalization of the work environment. And there's one other challenge possibly we see. If you can put an environmental monitor in a location and measure, let's say, dust environment there, and you say, okay, we're under the limit. Well, actually, the legislation does not say that. The legislation says if you can eliminate the harm or if you can substitute for less dangerous, then you have to do that first. Yes, be under the limit, but that's not the end point of your prevention journey. The next topic is digital labor platforms. And this goes far beyond what people have termed Uberization or whatever. And we do see different labor platforms providing different working arrangements. So you may have, yes, you may have a low skill tasks, so people delivering your pizza. Yeah, the platform allocates that person to a job, the person carries out the work on site, sends them to deliver your pizza. You may have a situation where that person is doing online work controlled by the platform remotely. At the other end, you may have somebody who may be let's say a graphic designer or a high skilled worker, and they will be getting jobs where they have the control. They can say yes or no to the platform. It's almost like a marketplace, whether that's on site or off site. But all these different labor platforms and approaches, they can be seen and they can worsen working conditions. They are often atypical employment. And if you're not careful, you can see some places where the status of employment is not clear. What they call false self-employment is a continual topic of discussion in the European Union. Yeah, who is employing this person? Is it the platform? If it's a temporary agency worker, for example, recruited through the platform, yeah, and they're going into another workplace, who's doing the risk assessment? Who's doing the collaboration between the employer and the site? Things like this. So these atypical arrangements can make it more complicated to do safety management, and it can challenge the employment rights of the worker. And finally, this digitalization monitoring, AI management, can lead to long working hours, work intensification, and these are psychosocial risks to the worker. One topic here, for example, is what they call black box management. Why do some jobs get allocated to some people? What's the algorithm behind it? Is it discriminatory? Is it based on your past performance? What is it based on? And not knowing how decisions are made is a major stressor. Next topic is advanced robotics and AI. So the artificial intelligence can be embodied in a robot or even non-embodied. It's just a smart application, for example. And again, as we heard with drones, potentially this is brilliant. You can take the person out from hazardous environments, confined spaces, for example, or from repetitive tasks that are going to cause musculoskeletal disorders. This is really an area that is developing and is very exciting, but quite potentially challenging. Is like, how do AI systems learn? What happens if they learn wrong? How can you actually generally do a risk assessment on a machine learning system? And there's a lot of discussion, a lot of work going on in here. And potentially there are very many benefits, but equally we can see some challenges. If I'm going to do a facetious example here, let's say, and this is happening, you are making hamburgers, you have a hamburger shop, and there is a robot that is frying the burgers. It has a thermal sensor, it has a visual sensor, so it can see how brown the burger is and how hot it is, and flips the burgers automatically with its arm, and tells until the burger is ready. Standing beside that is a worker who's assembling the buns, putting the salad in, things like this. This is happening now. So what happens? Who's controlling the pace of work? And okay, and what happens if a robot's sending messages back to the boss? This worker is not keeping up with my burger cooking. All of a sudden, who's in control? It's not the worker, and this worker can be suffering a psychosocial load. If I take that to the next step, maybe I put a nice little anthropomorphic head on my robot and it can speak to me. Again, this is normal technology. We can do this now. So the robot every morning says, "Hello, Tim, how are you?" How do I feel talking to a robot? There's a very strange issue there. Then it's quite foreseeable that you can plug that robot into your human resources system and your quality management system and your production system. And the robot says to me, "Hello, Tim, good morning. I see you were a bit slow yesterday working on your burger preparation." Okay, hold on. Is this robot now my boss? And even at the next stage, I can plug in my HR system, my human resources management system to this robot, this artificial intelligence system. And I come in the morning, the robot says, "Hello, Tim, it's a bit, I see you were a bit slow on the burger making yesterday. It would be a shame if your two kids' father lost their job because of this." Yeah. And this is a little bit facetious, but you see all of a sudden that interaction between the robot and the worker is becoming a major psychosocial risk factor. New forms of worker management based on artificial intelligence. We hear stories coming out of non-EU workplaces, particularly about the surveillance of workers in real time by management, driven by algorithms. Potentially we can have early recognition of worker health problems and identification of, say, bullying and harassment. But of course, we get the risk of micromanagement, amplification of existing bias, this black box decision making, surveillance of how often you went to the toilet. The worker gets stressed from continual surveillance, reduced job control. There's a lot of, if done right, excellent. If done badly, there is a risk of harm to workers. So just finishing off here, my key messages: technology is a tool. It's not what it is, it's how you use it. We have to have an inclusive human in command approach. Artificial intelligence must support and not control human decision making. Health and safety should be integrated into the development of digital technologies and its application from a design phase. Training and skills, again, we've heard this mentioned earlier, is essential for all workers. And the management has to include the impact of digital technologies in their prevention approach. And as it says in the directive 89391 EEC, the employer must adapt the work to the worker, and they have to adapt to a technical change, but they have to review their risk assessment to make sure they are still protecting their workers. And this means in particular the psychosocial risks of the worker. So I will finish here. There's some links to our publications I've mentioned in here, but I will be glad to answer any questions. Thank you very much indeed.
Thank you very much, Tim. As we say before also with Asterios, the world is transforming. It's not the future, it is now. So if someone has not understood that yet, he has to hurry and get in the new era quickly. So let's wrap up the questions that we have here. Let's starting with Michela. Michela, how Asterios asked how BIM provide real-time data and how you collect this.
Thank you. I assume this is a loaded question, really, from Asterios, because he knows the answer already, really. Drones, for example, could be a perfect example of how you feed BIM with data, real time. Any kind of sensor, either fixed or portable, wearable. It could be even a person being, say, for example, on site, having a tablet in hand and keeping notes. Really, this information can be fed back to BIM, really, and then be translated into a virtual model in practice. And, just I'm going to mention terminology here which may confuse some people, but actually BIM and digital twin so far have been used interchangeably, but they're not the same thing. Digital twin is usually the result of BIM. So what we see, the digital representation of the system we want really to operate is digital twin. So the digital twin is generated by feeding information and combining it through the help and of BIM. So this is all we need, really, information in any form or at any time as well.
Thank you very much. Another one is regarding, does BIM help safety to be perceived as a shared task amongst the design team and not just of the safety professional ones?
Yeah, I think that's an amazing question. I can keep answering for days, really, because part of my PhD, which was supervised by Dr. Yannis Dokas, who I believe is somewhere in the cloud listening to us now. So part of my PhD was around situational awareness. Asterios touched on that briefly. In academic, informal terms, what Dr. Panopoulos is talking about here is distributed situational awareness. So how do we perceive the safety levels together as a set of people? It doesn't have to do with specific accountabilities or responsibilities. How we design, we operate the system, we're responsible of the system, we understand the safety levels of it. And as long as we have access to BIM, all of us, irrespective of our title, of our post, we will be able actually to perceive all these safety risks that may be present in the system. So the answer is yes. Anyone can have access to it.
And we can say that the safety is more effectively managed through all this organization and design team.
Absolutely, because as I said, as long as you have access to the BIM system, and there I will open a parenthesis here, we try to do the same in high speed 2 in the UK. There are some concerns about license. Already Tim and Asterios mentioned GDPR and other perhaps intellectual property issues that people may find a little bit irritating. But as long as we go past that obstacle, really, and we're able to have access to this information, yes, we can act upon it irrespective of who we are and what our responsibility is in the system.
Thank you. Another one question from Mark. Michela, if you are aware, does this modular construction process compare or differ with the modular process used in shipbuilding, where prefabricated sections are transporting and welding together?
I mean, this is also a very nice question, and thank you, Mark, for asking it. I mean, I'm not familiar with shipbuilding. Perhaps this is the only industry I haven't worked in so far. But I think on the grand scale of things, as I said earlier, given that modular construction, meaning construction in a loose way now, diverting from residential, which was my presentation about. So anything that can be considered as modular construction, I think on the grand scale of things follows a similar process like the one I shared in my early slides, a flow chart, really. So I would assume that we can say apply similar recommendations like those ones I myself and my student made in the paper in other industries. I wouldn't see the problem really at all. As I said, the principle is like, Legos or what Tim mentioned earlier, just flipping burgers, really. It's just a matter of producing a final product. So yes, I would say in a very simplified way, yes.
Okay, and we have a last one for you. It is from Yegini, I don't know if I'm spelling it correctly. Who is responsible for machine and equipment inspection? How often should inspection be carried out? I assume this is a question regarding the site equipment, but
Yeah. No, thank you, Evgeny. I mean, that's a very good and practical question. Obviously, it's twofold. So when it comes to the first part of the question, really, who is responsible? I would very naively say the same person as before. Either you use BIM or not. It really doesn't matter. And it wasn't. We didn't go in the paper into such level of granularity to be able to tell you really who is going to be responsible. As I said, my assumption is the same person, really. When it comes to the second part of the question, how often, there were some mentions in the papers we had analyzed that it's highly likely that we can't really define the pace or the frequency of inspection, because the safety levels are monitored dynamically. So we will interfere or intervene as and when needed, because say, for example, if we have a degradation of the safety levels, we have to interfere there and then. So it's not a matter, of course, of regular inspection. But given that it can give us it is a dynamic tool. BIM is a dynamic tool, as Tim and Asterio said. We are talking about tools here. So BIM is yet another dynamic tool. Then the answer is that it can even decrease the frequency of inspections, because we actually have visible access to the physical system without actually needing to be there on site at all times. So yes, I don't know if that covers really the question.
Thank you, Michaela. One question for Asterios. Okay, this is the new technology that you present to us. I don't know if you have managed until now to quantify the advantages, for example, in terms of cost or from time saving or risk level reduction until now from the application of this process and tools.
As a practitioner, I'm usually allergic to quantification, but it seems too academic to me. But anyway, the short answer is no. We haven't really quantified it, but we have a very good understanding of the order of magnitude, meaning visual inspection of lighting pillars. If you do it with a crane, it takes weeks and it costs tens of thousands of euros. If you do it with a drone, it takes days and it costs less than 10,000 euros. So it's an order of magnitude in time and an order of magnitude in money. In safety, it's even more, meaning that using a crane or a scaffolding exposes people to working at height and related risks. Holding the control of a drone is more or less zero. I'm not literally saying zero, but anyway, compared to the other is zero, meaning 2 or more orders of magnitude of risk. So this is a very short way to show this. In other cases, it can do things that people cannot do, period. Meaning, for example, you cannot inspect a flare while it is in operation. You cannot effectively detect leaks in a refinery in elevated equipment with stationary detectors or with handheld detectors, unless you do an investment which is, I don't know, gigantic. So sometimes it's an order of magnitude savings in time and money and more in risk. And sometimes you do things that you couldn't realistically do.
So we can say that in terms of cost and money, it is more easily to quantify it, obviously. In terms of risk level and safety, because if we remember the pyramid of controls hierarchy, since we eliminate risk, exposure to risk, so we expect that this will be beneficial to us, of course, in the process and in the future, in our incident rates, etc. Thank you, Asterios. One question for Tim. When the legislation will be in line with practice, this is from Emilia, sometimes the rules are not so smart and flexible according to the activity, not the process.
Thank you very much. Well, as a former labour inspector, I would say my quick answer would be the legislation is in line with practice because you have the Framework Directive 89391 EEC that protects all workers from all hazards and risks, and it is a duty on the employer to protect the workers, and also protect people, for example, who are working on their site, for example, working with the other employer. So in some ways, yes, the legislation is always there. Yes, also, but legislation is never state of the art because, if nothing else, the legislative process can take several years. What we may be lacking at the moment is what we might call norms, as in a general way. So I heard one example is like, how do you actually do robot maintenance? Yeah, do you have how do you do that safely? Is there any standards upon which doing that? Yeah, do you have to stop the entire system? Whatever. Or, you know, how do you use drones? I mean, there will not be any specific legislation which is the use of drones directive for health and safety, but you have to take the framework of directives and legislation you have at the moment and say, okay, let's do the risk assessment, find out the control measures we need in place. One of the challenges with digitalization is it crosses beyond occupational safety and health law. So yes, I've mentioned the Framework Directive and everything else, but then there's employment law. And this is where things like right to disconnect, atypical employment patterns come into play. Under health and safety law, you may be compliant, but if you are not declaring that person as an employee, for example, then there are issues, and that employment law may be changing. This is outside my area, but this is where you are talking about platform economy regulation. It's not so much about health and safety, it's about employment law. And the third area is the supply law. So we've had for a long time the supply of machinery regulation. This is market surveillance. This is prevention of dangerous machinery entering into the workplace, entering into the European Economic Area, in fact. Now that's up for, it's being rewritten now and trying to bring it up to date. But again, it will always be chasing up technological changes. And we see there, though, you can add in extra references to robotics or whatever. But it will be saying, look, you still have to go back and in fact assess the risks of this machinery. Is it securely fenced? Is it producing loud noise? Is it producing dangerous fumes? Is it producing risk to workers? And you will have that market surveillance side. And as I say, finally, the data protection. It'll be interesting to see if there are changes in data protection legislation. If you're flying a drone around and you capture me on your drone video footage, and I'm not a worker, what happens there? I have a right to privacy. So legislation is there, OSH legislation is there. We will get, it is not specific legislation. It is always, you work within this framework. The days of having a legislation that says, at least at the European level, you will have X number of toilets per worker, you will have this and this and this and this, and you must not do this, 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 this. That's not how modern legislation works. But it is a challenge if you are at the forefront on this topic. I'm just conscious of time, but for example, exoskeletons. If you have exoskeleton, is it for personal protective equipment? Is it a piece of work equipment? Or is it in fact a medical device? And how you bring it to market will depend on its final use. Even though it's an identical product, you may have to go through 3 different lines of certification. So there are challenges in legislation and regulation, but my answer would always be go back to basics, go back to the starting point. What does your risk assessment say? What should we be picking up?
Thank you, Tim. Thank you, all of you, Michaela, Asterios, Tim, for your very interesting presentation and very critical topic that we discussed, present and discuss. Our session is closing. Thank you, participants, for the view, and we'll be back in 15 minutes after the short break. Thank you very much, Tim, Asterios, and Michaela.